So today we're going to be making a shake flashlight.
So this was my first attempt at a flashlight. I used this red magnet wire from Radio Shack, which didn't really work that good because there was too much of a coating on it. So to start this shake flashlight, I have a piece of PVC pipe about 8 inches long, and I marked where the coil is going to be made. So what I'm going to do is wrap a copper magnet wire around here to make a coil and have these neodymium magnets go through there. So the principle here is Faraday's law. So there's going to be a coil here, and when this magnet slides back and forth through the tube, it's going to change the magnetic field, which induces a current into the coil. Now this current in the coil is AC because you get a pulse one way when the magnet goes through, and then you get a pulse the other way when the magnet goes through the other way. So we'll have to convert this to DC. So here I have a coil of wire, or it's coated copper wire out of a TV, and it's got to be enamel coated so that you basically just don't have a chunk of copper and it's actually a coil. So I'm gonna start wrapping this coil around here. So now we're like 3/4 of the way done. So now 15 minutes later, we have about 500 feet of wire wrapped around the pipe in our coil. And I'm going to put a bead of hot glue down the middle to keep it from coming undone and turning into a giant mess. So now we've got our two ends of the coil, and we're going to put the magnets in here. There's about 9 neodymium magnets that fit perfect inside the copper tube. And we're going to put the end caps on so the magnet stays in. And I'm going to tape the caps on so that they don't fall off and break like they did before. Make sure it's nice and tight. Alright, so we have the body of the flashlight now. But the problem is that when the magnet goes through that way, or the magnet goes through that way, the current switches each time you go through. So since an LED is a directional light bulb, a light emitting diode means that with a diode, the power can only go through one way. So the light bulb only lights up every other time that you shake it or turn it over. So we need to find a way around that. And the way around that is with this little bridge rectifier. And what that does is these two red wires are your AC power going in, and then your two white wires are DC power going out. And when the AC power goes in, it's also called a bridge diode or a diode rectifier. It's got 4 little diodes in there, and since a diode's like a little one-way valve for electricity, when you cross that, the alternating current coming in turns into only DC going out, so all your pulses are in the same direction, which lets us light up the bulb. So here's a diagram of the circuit. We have our coil with our AC power coming out, going through the rectifier, and then our positive comes out. We have a bank of 4 capacitors in parallel. They're all 2200 microfarad each, so that gives us 8800 microfarad total. And then in parallel we have our LED with the anode, the positive side, being hooked to the positive side of the circuit. And the negative side has a switch on it so that we can shut the bulb off when we want to. So on these capacitors, this little white strip is going to go to the negative side of the circuit. So in parallel, we're going to hook all of the positive sides of the circuit together. And these capacitors I've soldered wires on so that I can make things go a little quicker in the video. Twist all those together. And then all of our negative terminals are also going to go together. Alright, so I just put a little hot glue on these wires to keep them from breaking off again because my soldering sucks. So now we're going to keep going and hook all of the negative sides of the capacitors together to make our parallel circuit. So we have the positives hooked together and the negatives hooked together. And I have the rectifier's on a little piece of circuit board I got here. I'm gonna hot glue the capacitors to the board to make things a little neater. So now I have a little switch here wired to the negative side of the LED, and we have the positive side of the LED here. The way you tell on an LED, you can't tell under this tape, but the positive side has a longer leg than the negative side does. Positive side's the anode, by the way. So that's going to go with the positive side of our circuit. And I didn't show me soldering any of the stuff in here because I didn't want you to have to watch an hour of how not to solder. So now we have our switch and our LED attached. This leaves us with the two terminals for our coil. And since this coil is coated wire, to make sure we get a good connection, I need to burn the coating off. And you can see the wire turned black because the coating was burnt. I'll do this again on the other side. I'm going to clean this up with a little bit of sandpaper before I wire it to our circuit. It doesn't matter which side you wire to because it's alternating current. And I'm going to go solder these. So now that I've got these things soldered, I'm going to put some tape on them to insulate them and also to make sure they don't fall apart. And now our circuit is done. And so I should be able to shake for a little bit and then flip the switch and the light will come on. So now that should have stored up some charge in the capacitors and we'll have our light. And if you shake some more, it stays going. Now I'll glue all this to the stick to make it look a little bit cleaner. Going. Alright, so there it's all together in one piece. It's not the prettiest thing, but I wanted to keep all the components separate so that I could easily demonstrate when I put it together. So I'll give it a shake again. Flip it on. Our blue light, nice bright blue LED. And you can flip it off. So there's your shake powered flashlight. And I'll go back through the theory of it one more time. So we have our coil here made of magnet wire that I stole out of a TV. And there's probably 400 to 500 feet of that in there, so that gave us a lot of windings, which is good for producing more voltage. This one didn't have as many windings, and I don't know if you can see or not, the wire is mostly the plastic coating, so that didn't induce a current as well. So we've got there's 9 neodymium magnets that slide back and forward in the tube, and each time they go through, they induce a wave of AC on the coil. So originally, when I just hooked the LED light up to the coil, that you'd have to go in a certain direction to get the light to light up. It only light up when you tip it one way. So then I decided I needed a bridge rectifier, which is also called a diode bridge, inside there. And when you cross the diodes, it only lets power go through one way, giving you a direct current. Then I have a bank of capacitors stolen from that same TV, and this was the max, the biggest ones I could find, and I put them in parallel to make sure I could get the max capacitance without having to go buy an expensive capacitor. And then I have our LED light bulb, which is light emitting diode. So that is directional. The power can only go through one way for it to light up. So that's also in parallel with the capacitors, and I just have a little switch that allows me to stop the current going through the LED when I charge up the capacitors. Shake it up for a little bit, flip the switch, got a nice bright blue LED. And there's the shake flashlight.